Hey guys, Mr. Manise here again, and I'm going to explain the probability quiz that you guys took last week. Class average on this was an 86, which is pretty good for not such an easy unit. So let's go ahead and jump in here. I'm actually going to go through, this is the normal key that I give. Normally this is an open response quiz, so I guess that is one benefit for you guys learning from home. I know it kind of stinks to have to learn from home and not have that face-to-face one-on-one interaction, but at the same time a lot of this stuff is multiple choice and you can use your notes, so I guess it kind of all evens out in the long run. But let's go ahead and jump in here. So number one, it says a standard number cube is rolled. Standard number cube is rolled. Six-sided. What's the probability of rolling a number less than 5? We have 1, 2, 3, 4, 5. The probability of rolling something less than 5, we have 4 options out of 6. That is 2/3, so that was B. Number 2, on the percentage line, where does 64% fall? 0.5 is 50%, 1 is 100%, so obviously we're going to fall somewhere between 50 and 100. So D was correct on that one. Going back to my old quiz, these are all the same exact questions. If a bag contains 3 white, 4 red, and 5 blue, what's the probability of selecting a red and? There's that word. When you see the word and, pull back up our graphic organizer. In the question, if you see the word and, then we are going to multiply our probabilities. In the question, if you see the word or, we are going to add our probabilities. So if you got those confused, then yeah, you probably made a score that you weren't very happy with on this. Critical words. Okay, but in this one I see the word and. And then it also says without replacement. So remember, when it's without replacement, the denominator drops because I'm pulling a card out of the deck, or excuse me, this is pulling marbles out of a bag. So I'm pulling, it wants the probability of selecting a red. Okay, so that's 4 marbles out of a total of 12. And then selecting a blue marble without replacement. So there are 5 blues, but it's not out of 12 anymore because I didn't put it back. I took the marble out of the bag and I left it out of the bag. So there aren't 12 marbles anymore. There's only 11 marbles left in the bag. And I see the word and, so I'm going to multiply those, and that gives me 5 over 33, about 15%, which was D on your quiz. Excuse me, C, letter C, 5 out of 13, C on your quiz. All right, next one here, cards chosen at random from a deck. It is then replaced. So if I put it back, the denominator does not change. A second card is chosen. What is the probability of selecting a face card and selecting an ace? So that's 2 different events. So the chances of pulling a face card out, there are 12 face cards. There are 4 jacks, 4 queens, and 4 kings. Those are the cards that have a face on them. All right, and then I'm going to put it back, and the chance of selecting an ace is 4. There are 4 aces out of the deck, but the denominator does not change. I see the word and, so I'll multiply. That gives me 3 over 169, which was letter A for number 4 on your quiz. The next one, from 12,000 remote control cars, the inspector found that 6 out of 325 were defective. So estimate the total number of defective cars. There was one just like this on the quiz review. So basically I just want to figure out what is the percentage, what are the chances I'm going to get a defective part. Okay, that's going to be 6 out of 325, whatever that percentage is. 5%, 2%, 3%, whatever that is. And I'm going to take that and I'm going to multiply by the 12,000 different cars. Now, when you did this on your calculator, you get 6 divided by 325 times 12,000, you get that number, okay, 221.5. But what did my instructions say on this problem? It says round your answer. What's that word right there say? Up. Okay, round your answer up to the nearest whole number. So that rounds up to 222 cars, which was answer choice C. Okay, the kittens. I love kittens. We have 2 cats. My daughter loves cats. In a litter of 8 kittens, there are 2 brown females, 1 brown male, 3 spotted females, 2 spotted males. If a kitten is selected randomly, what is the probability that the kitten will be brown or? Okay, there's the word or. So when I have the word or, I'm going to add my probabilities. What are the chances is brown or not female? Well, that's kind of confusing. Well, not female means what? Okay, not female means male. So it's basically asking you, what are the chances it's going to be brown or male? Okay, so how many brown kittens do we have? We have 2, 3. We have 3 kittens out of 8 that are brown. I'm going to add that to how many males do we have? I have 1 male plus 2 males. I also have 3 males out of 8 kittens. But when I see the word or, when I add my probabilities, remember the difference between exclusive and inclusive. All right, so if it's exclusive, they can't happen at the same time. If it's inclusive, then there is some overlap. Is there overlap? Can I be brown and male at the same time? Yes, I can. How many are brown and male at the same time? This guy right here. I have 1 brown male, so I have to subtract that out of my probabilities. Just like in the graphic organizer, it says if it's inclusive, then I have double counting. I cannot count that brown male here and here. I can only count him in one of the spots. So I have to add this the probabilities and subtract out the overlap. Okay. So subtract out that 1 brown male. That gives me 5/8. Okay. Well, 5/8 is not one of your options. So the correct answer was E on that one. But 5/8 technically was the answer. Okay. Number 7, which is this one on my old quiz right here. Spinner has congruent regions marked 1 through 18. What's the probability that the spinner will land on a number less than 5 or a multiple of 2? So I see or, I'm going to add. And then I have to ask myself, do I have to subtract out any overlap or not? The chance of being less than 5 is 1, 2, 3, 4. Okay, so that's 4 of them out of 18 that will be less than 5. And then how many are a multiple of 2? Well, that's just all your even numbers. That's half of them. So if I add 4 over 18 plus 9 over 18, the question is, do I have to subtract out any overlap? Yes. 2 of them are both less than 5 and a multiple of 2. And that's going to be these two guys. 2 and 4 are less than 5 and they're a multiple of 2. So I have to subtract out both of those overlaps. And that gives me 11 out of 18, which was letter A for number 7 on your quiz. Okay, the next one, we got the chick flicks in the box. All right, she's reaching in there, she's pulling out, she wants to know the probability of pulling out a chick flick and without replacing it. So I already know that I'm in and land, okay? I'm in independent land, independent land. And, so there's the other and, so actually both of those ands work. And picking another chick flick. So when I see the word and, I'm going to multiply. So the first time she reaches into the box, the crate, there are 8 chick flicks out of 20. Okay, so she takes out, here's a chick flick. She takes out that chick flick. Now when she goes back into the box, there aren't 8 chick flicks anymore. There are only 7 chick flicks because I already have one of the chick flicks outside the box. So there's only 7 left, and I don't have 20 movies in the crate anymore. I only have 19 movies. So when you multiply those, that comes out to be 14 over 95, which was answer choice D on number 8. Okay. Number 9, the lunch pail question. We've got 6 appetizers, 7 dishes, and 8 desserts. So to find the combination, I just multiply all 3 of those together, and that comes out to be 336 different combinations. All right, there are only 365 days in a year, 365.25 if you want to be technical about it. So no, I cannot eat the same I cannot have a different combination every day because I'm going to run out. The correct answer was D. On that 337th day, I can eat a different combination all up to 336. But on the 337th day, I'm going to have to repeat a combination. Okay, and hopefully you guys know how many days are in a year. It kills me. Every year I have at least 4 or 5 students who come up to my desk and say, and they'll kind of whisper, they're like, Mr. Manise, how many days in a year? They know they should know it, but their mind just slipped. Well, it happens to all of us, but it's funny every year that happens. All right, number 10, a card is picked out. Well, let me go back to my sheet here. A card is picked at random. What is the probability of a diamond or a 4? Okay, so there are 13 diamonds. That's a fourth of the deck. 13 diamonds plus there are 4 4s out of the deck. Is there any overlap? Can I be a diamond and a 4 at the same time? Yes, I can. One of those cards is the 4 of diamonds, so I have to subtract that out, so I do not count him in both of these spots. That comes out to be 16 over 52, which reduces to 4 over 13, which is C for your quiz. Okay, the next one here, which is actually a different number on my original quiz. It's the same problem down here. This one, all you had to do is you just had to take the probability of A times the probability of B and see if it equals the probability of both of them happening. 0.2 times 0.72, that does not equal 0.18. So the correct answer was D, no. Okay, they don't match. You can take out both of those. No, they are not independent. Okay, they're dependent because the left side does not equal the right side. Okay. I don't know what that is, but it sounds like a pretty good place. I don't know. Okay, number 12 on your quiz was number 11 on my old one. It says, all right, it says all the same data here. We got the spinner. They ran a bunch of trials. They spun it a bunch of times, 60 times. What's experimental? Okay, experimental is what actually happened. Okay, when they ran this guy, how many times did it land on a 3? Okay, how many times? It landed on a 3, 4 out of, what's the total? You got to add all those up. So if you add all those up, that's a total of 60 times. Well, they told you it's a total of 60. Okay, so that's going to be 4 out of 60 times, which is 1 out of 15. On this back page, I started using percentages instead of fractions. But if you just plug that into your calculator, that comes out to be 6.7%. Based on their results, 6.7% of the time they landed on a 3. Number 13 says, what's the theoretical? Okay, with theoretical, I don't care about the data. I don't care anything about that information. What is supposed to happen? The chance of landing on a 5 should be, based on an 8 spinner, that should be 1 time out of 8 times, theoretically. All right, that comes out to be 12.5%, which is B. So you've got to find these trigger words. Number 14, now we're back to the chart. When I see the word experimental, now I'm looking at this data. Experimentally, what's the probability of them landing on an even number? So even would be 2, 4, I'll put the triangles around this, 6, and 8. So I've got to take 12, add that to 8, plus 9, plus 9. If you add all those up in the triangle, you got 19 of those out of, you got 38 out of 60. That reduces to 19 out of 30. Yeah, so 38 in the triangle. That's the number of times they got an even number. 38 out of 60. And that comes out to be about 63.3%, which is answer choice C on your quiz. Number 15. I can see, I apologize. It was not my intent for this to be confusing. As soon as the first person sent me a message about this one, I was like, oh man. I didn't even think about that, but I could see how there was some confusion. That's why I immediately sent out that Remind 101 text to you guys to let you know that C, answer choice C, was 0.60. I would not be mean to you guys. I would not do that to you. But C was exactly 60%. What is the theoretical? Theoretical means I don't care anything about the chart. I'm not looking at that anymore. What's supposed to happen? Theoretical probability of rolling a number less than 6. That's going to be 1, 2, 3, 4, 5. So that's going to be 5, or excuse me, there are 8 on this spinner. Okay, so that's going to be those guys, 5 out of 8 possibilities. And that comes out to be actually 62.5%, which does not equal 0.6. Okay, so the answer was none of those. Okay, home stretch here. Okay, and then we got our Venn diagram right here. So we got some guys that are dancing. I don't dance. I can't stand dancing. I probably look like a robot. I look like an idiot. I love to play music. I can play music on stage, but as far as getting me out there on the dance floor, that's must-see TV, because I'm sure I look like a moron trying to dance. I don't see how people do it. But we all have our own talents. All right, so we've got a bunch of numbers here about these kids, these boys doing these different dances. Number 16 says how many boys are enrolled in the school. So you basically just count up every single number that you see. There were no boys outside. So every single one of these boys, I guess that makes sense, right? They're all enrolled in stage school. So why would there be a boy that doesn't dance at all? Okay, they just need to drop out and go play baseball or something. Okay, so how many boys are enrolled? Count up all the numbers. That was 66 total boys. Okay, now this is a problem that happens every year when I give this quiz, and I try to give everybody a heads up. Hopefully you guys did your quiz review and you had it out there by your side. But notice that each of these problems are asking for something different. What does this say right there? That says how many. Okay, there's a big difference between how many and what is the probability. Okay, if I say what is the probability that it's going to rain tomorrow, you would not say 40. Okay, that's not a number. You give me a percentage, 40% chance. There's a 4 out of 10 chance that it's going to rain. Okay, this is how many. That's a physical number. How many boys dance all 3 styles? Okay, that's the guy in the middle, right? Okay, there are 20 boys that dance all 3 styles. But now notice for the rest of the questions, it says what is the probability? Okay, now it's not a hard number anymore. Remember, probability is the number of favorable outcomes over the total number of outcomes. So probability, that P stands for probability. P, P, P. Okay, so the rest of these are probability. Okay, so we're not looking at any hard numbers anymore. So you can throw all these numbers out, because every year I have students that will give me hard numbers instead of the actual fraction or decimal or percent. Okay. So number 18 says, what's the probability of a boy dancing salsa only? Okay, so that would be this guy up here. Oh, yeah, sorry. So salsa only would be this guy right here. Only 9 of them dance salsa only. Okay, so that's going to be 9 out of the total of 66. And that comes out to be 13.6%, which was B. Okay, now here we've got our Venn diagram notation, the complement, the intersection, the union, the overlap, all that good stuff from day one, the first lesson. So this is union. Okay, remember union means give me everything. Give me everything in J, give me everything in T, and give me the overlap. I'm gonna do this. I'm gonna have to do this in different colors since I can't erase this. Okay, give me everything in J. Okay, everything in J. That's going to be red. All these guys in red are in J. Give me everything in T. Okay. All right, let me do this in a different color. Actually, I guess I'll just keep this red since I'm doing different problems. Everything in T, that's in red, that's in red. We've already circled these. Okay. So basically, it's everywhere I've circled something red. That is the union. That is J, that is T, that is the overlap, that's everything. So if you add all those up, 4 plus 16, 5, 20, 9, 3, if you add all those up, that comes out to be, let's see, that comes out to be 57 over 66, which reduces to 19 over 22, and that comes out to be 86.4%, which was D. All right, the next one was just not T. Okay, so give me everything that's not in T. Okay, so that means I'm going to put the green there. I'm going to scratch all those out. I don't want anything in T. That's the complement. So I just add 4, 16, and 9. That's 29 out of the total of 66, and that came out to be 43.9%. Okay, now number 21, T upside down U means the intersection. I want the intersection of T and S. So that's the physical, the literal overlap. T and S, that means where the salsa circle intersects the tango circle. So I'll put a square. That's going to be that guy and that guy, the 20 and the 9. Add those together, and that gives you 29 out of the total of 66. And that came out to be also be the exact same number. Is 20, 43.9%. Okay. All right, and then the last one. Okay, the last one here is the probability of not S minus J. Okay, not S minus J. I'm going to redraw these circles real quick because that's getting kind of messy. So give me just one moment here. Okay, so we got 4, 16, 25, 3, 9, and 9. Okay, did I do that correctly? Yes, I did. Okay, so I want, this is J, S, and T. So I want not S minus J. Okay, so let's circle all of our not S's. So again, I used the card, the playing card when I taught this lesson, cover up everything. I don't want anything with S. That's going to be my 4, 5, and my 3. So from that, from these red guys, I want to subtract out the J's. So I want to, only from those red guys, I want to take out the J's. That's only going to leave me with 3. And 3 out of the total of 66 comes out to be 4.5%. So that's it for this quiz, guys. Again, good job. Pat on the back if you made an A and you got your 5 points for turning it in on time. And that's it for this video. We'll see you on the next one.